Hey everyone, in this video we will be doing properties of water experiments. The first experiment involves pepper and soap. The materials you will need are pepper, a bowl and water, and some dish soap. The first step is to fill up the bowl halfway with water. Then you will add some pepper to the bowl. Notice how the pepper is evenly spread out on the surface of the water. So why does the pepper float? The pepper floats because it is hydrophobic and relatively light. In addition, water's surface tension helps it stay afloat. Surface tension is the property of the surface of a liquid that allows it to resist an external force due to the cohesive nature of the liquid's molecules. In this case of water, the various intermolecular forces, or hydrogen bonds between the water molecules, draws the molecules together. The pepper distributes its weight evenly across the surface of the water, and it is spread out far enough that it can float on the hydrogen bonds. So the next step is to add some dish soap to a small container. Dip your finger into the dish soap, and then dip your finger into the bowl. Did you see how the pepper spread outward to the rims of the bowl? The key concepts involved in this experiment are surface tension, hydrogen bonds, and hydrophobic versus hydrophilic. Adding soap to water breaks the hydrogen bonds between water molecules and increases the distance between them, causing the surface tension of water to decrease. The pepper moves away from the area where the soap was added because the soap breaks the hydrogen bonds, causing that area to have weaker surface tension. Since that area can no longer support and help the pepper float, the pepper shifts away. Soap is a long molecule with a hydrophobic end and a hydrophilic end. The hydrophilic ends of the soap break the bonds between water molecules and form a layer of soap on the surface of the water. The pepper tries to move to the area where the hydrogen bonds are still intact. However, as time passes, the soap spreads over the entire surface of the water and causes the remaining hydrogen bonds to break as well. As a result, some of the pepper sinks to the bottom of the container. The second experiment involves water and string. We will be pouring water from one container to another, which may sound weird, but it will make sense later on. The materials you will need are a container, some string thicker than sewing string, and a cup of water. Dip the string into the water so it is fully soaked. Normally when we pour water from an angle like this, the water does not pour into the container. Instead, it misses it. So why does water flow downwards? Water flows downwards due to the force of gravity. Since water has mass, it is easily pulled down by gravity. Also, water has inertia, or resistance to change, so it continuously flows at a constant speed. Now stretch out the string between the cup and the container below. Pour out the water slowly over the string. Notice how the water sticks to the string and successfully flows into the container below. The key concepts involved in this experiment are cohesion, adhesion, hydrogen bonds, and water polarity. This activity was possible due to water's properties of cohesion and adhesion. Water molecules are cohesive, which means they form hydrogen bonds with one another. These hydrogen bonds are intermolecular bonds. The hydrogen atom of one water molecule forms a hydrogen bond with the oxygen atom of another water molecule. The hydrogen bonds hold the water molecule together, allowing the water to travel together like a column down the string. Water molecules are also adhesive, which means they form hydrogen bonds with polar surfaces. The water molecules are able to cling to a different molecule due to water's polarity and electrostatic attraction. Water is polar, allowing water molecules to have a positively charged end on the hydrogen side as well as a negatively charged end on the oxygen side. These positive and negative ends attract to the polar molecules in the fabric of the string, allowing water to cling to the string and travel downward collectively. Thank you so much for watching, and I hope you learned a lot about the properties of water.